Hey guys, okay, so we're on the last lesson for chapter 7, periodic table, and basically it's going to be pretty short. We're just talking about mostly physical properties and physical changes, which we've seen a little bit about, we've had a little bit of exposure to, so there'll be a few things in between, and then you guys will be finished. So first, we're going to talk about physical properties. So physical property is any characteristic of a material that can be observed without changing the identity of the material itself. So basically, you can look at a material, turn it, look at it, perform different observations on it, but it won't change the actual makeup of the thing. So if you're trying to do the physical properties of a piece of paper, for example, like your piece of paper your notes are going on, you can look at it, pick it up, turn it upside down, flip it over, and you can see the color, the length, and the shape of it. Those are all physical properties that we have here on the screen. That also includes the boiling point, the melting point, and the density, as well as other characteristics. So if you're looking, it's a physical property is something you can look at and see without changing what the material is that you're looking at. So I can observe my piece of paper my notes are on and talk about the different physical characteristics of it without changing that it's still a piece of paper. That's basically what physical properties are. So here's what you're going to put in your box. Okay, I want you to do this spider diagram or concept map. So physical properties in the middle. And these are the different ones. Color, shape, mass, volume, boiling point, melting point, density, volume, weight, magnetic ability, state of matter, texture, luster, solubility, ductility, that's the wire ability, and malleability to be pounded into sheets. These two apply specifically to metals. These other ones apply to anything else. Okay, so melting point, we talked about this before, simply is the temperature at which a solid changes to a liquid. So melting point is where you have a solid and it melts to a liquid. Okay, then you have boiling point. So boiling point is the temperature at which a liquid changes to a gas. So water heats up and begins to boil, and then you get the water vapor, changes to a gas. We've gone through that, and that's pretty simple. The next one is thermal conductivity, and that's the ability of a material to transfer heat at collisions between the particles. So basically, you get an example like a metal in a pot or a pan. The reason pots and pans are made out of metal is because if one part of the metal is heated, its particles move really fast and collide with nearby particles, transferring that heat or that energy. So this is fairly common sense. Thermal conductivity, that's how much heat can be transferred by collisions. Things like metals have a high level of thermal conductivity because the particles move so fast and they transfer heat so quickly. You wouldn't want to make a pot or a pan out of plastic because the transfer of heat by collisions is not nearly as high. Then you have electrical conductivity, and that's the ability of a material to transfer electric charge through a material. So similar to thermal conductivity, now we're just talking instead of heat about electrical charge. So thinking of metals, remember they have those metallic bonds which allow the electrons, valence electrons, to move freely, that sea of electrons in a metallic bond in a metal, and they're able to carry a charge, and they have a high electrical conductivity, and that's why they're used so much for wire or things that need to transfer electricity. So again, electrical conductivity, how much electric charge can be transferred through material. And again, metals are very good at that because all the electrons move freely, and that allows the particles to carry that charge. Then lastly, a physical change, and that's any change in the size, shape, or state of matter in which the identity of the substance is unchanged. So it's again similar to thinking about physical properties. You can observe or do something to the material that doesn't change what that material actually is. That's a physical change. So dissolving, mixing, filtering, which is separation by size of particles, and change in state as well as other changes are all physical changes. So for example, okay, physical changes examples, this is going to go in your box. You've got the changes of state here, okay? So you have the red arrows go in one direction and the blue go in another. So if we're following red, you've got freezing, and the opposite process of that is melting. So freezing, so going from liquid to solid, from solid, this is sublimation down here. But if you're going freezing and melting, so going from liquid to solid, solid to liquid, or if you're going liquid to gas, gas to liquid, okay, and then it has sublimation down here on the bottom. So any change of state is a physical change. Here, this is an example of dissolving. So you've got water and sugar, you mix it, okay, maybe heat it up a little bit, and the sugar dissolves. That's physical change because the sugar is still sugar, the water is still water. Now they're just mixed together, okay? And this is just an example of mixing two different colors of paint. Okay, although the color might change a little bit, you're not changing the identity of the paint as a substance. It's still paint. So physical changes are things that happen that keep the materials the same. For example, if I was to take a piece of paper and I was to tear it in half, it would still be paper. I haven't changed the chemical makeup of the paper, just the fact that it may have been larger before. That's a physical change. So hopefully that was very simple, short, and we will move on following this later. Okay.